Welcome back, everybody. We're starting Chapter 2 on one-dimensional kinematics. And kinematics is a word that has the same root that kinetic, or if you go into kinesiology in college. I had a lot of contemporaries in college who were in kinesiology, that is the study of active things. Kinematics means things that are moving. And it refers to things' position, their speed, their velocity, and also their acceleration as well. And that's what this chapter is going to deal with. But this video is just going to focus on Chapter 2, Section 1, and that is on the concept of position, displacement, and and distance. Position, displacement, and distance. All right, so here we go. So position is your location with regards to some sort of coordinate system or some sort of origin. For example, this guy's position right here, we call that x1. And by the way, position, x is going to be our notation for position, or at least horizontal position. X1 or x initial, his position is actually some distance away from the origin right here. So if we call that 0, then his initial position is, 3 meters from the origin, okay? So it's in reference to some point. Now, he could be starting at the origin. He could be starting at 0, which is fine. In many cases, you'll be told that a person or an object begins at the origin, starts at 0. But it's not necessarily always the case. So it's with regards to a coordinate system or starting at 0. Or to a 0 point somewhere. And then, of course, you have him moving to a final position. The final position, x final, is that right there. So he has undergone some change in position right there. Some sort of change in position. So it's all with regards to a coordinate system that has a 0 point somewhere. Okay? So if you change your position, you move some distance, or you undergo some displacement. You are displaced from your original position. But these two things, distance and displacement, are actually two different concepts. They're very similar, but they are different in that distance is what we call a scalar quantity. It's the total length of a path taken, and it could be in a straight line or it could be in a curved line. All right. We say that it's a scalar, which means that it's always positive. That means whether you're walking north, south, east, or west, you're always gaining distance. So say if you put a pedometer on, many people wear them around, so it tracks your footsteps. It doesn't care what direction you're going. It totals up all the length that you've moved. By contrast, displacement, and we call that delta x. Now remember I said that x was going to be our notation for your position. Displacement was what's called a vector quantity, which means it's got a value, it's got an amount that you have moved, but also what also matters just as much as the amount is the direction that you've moved. Okay, so let's pretend for a minute right here that we have a coordinate system where here's our origin. All right, so that's 0 right there. And we've got a person that's moving. All right, we've got a person that is walking in that position, and we'll call that direction the positive direction, and this positive the negative direction. They might be displacing themselves a positive 3 meters from where they started. All right, but similarly, you can have a person moving this way, and we say that they're displaced negative 3 meters or some distance in the negative direction. Now, can you really walk negative 3 meters? No, you can't. The way we measure our distance in real life, it tends to be we just add up the distance no matter what direction we're going. But when we do problems in class, having this positive value or this negative value right here is going to be very important. So distance is the total length of the path. Displacement is going to be the change in an object's position. Another way to illustrate this would be to kind of think of a track, like track and field. All right, so here is the track, like outside your school. All right, and you've got a starting point, that is a starting line, and a finish line right there. And this red person right here, stands here. and then as the gun goes off, they travel all the way around the track. Okay, so you might say their distance equals 400 meters. I believe that's a pretty standard track length. Okay, but if they start here and they end here, so their beginning position and their final position is the same, we can say their displacement is 0 meters. Because in that whole amount of time, they've really gone nowhere. They wound up in the same spot. Now, tracks are circular for a reason, so that you don't have to run, several miles and then have to get a ride back. You wind up at the same spot for a reason, because we want to keep tracks kind of compact like that. So you wind up at the same place. So your displacement can be 0, even though you kind of made some distance around the track right there. But that's the main difference. Displacement, or you might say the delta x, your change in displacement is really 0, even though your distance around the track is 400 meters. By the way, our SI units, or the International System units, that we're going to be using are meters per second. That's a standard unit of length. I'm sorry, I'm getting ahead of myself. No, false. Not meters, and I'm not even sure if I can erase this right here. Can I? No, that's going to erase everything. I'm getting ahead of myself. Meters. I'll just box that right there. Meters is a standard unit of length or distance or displacement that we use in the metric system. Okay, you can convert that to kilometers or centimeters if you want, but meters is going to be the primary unit of length that we use. So, if we have a delta x, and in fact, let me change this right here. Let me change the color. This is going to be important. If we have a change in position, delta x. Delta, by the way, we always should write an arrow over this value, displacement, because that indicates that it's a vector, that positive and negative, that you can have positive or negative values. Wherever you see delta x, delta means change. All right, and that always means your final position minus your initial position. Okay, that's big right here. That's going to be a big idea. You're going to see delta x, that should be a closed triangle right there. You're going to see lots of deltas all throughout this course. And that means final minus initial. So if somebody starts at, see here's the origin right here. All right, and that's a pretty bad flat line. Let's try that one more time. Here's our origin. There we go. And they start here. We'll say that they start at 2 meters, and they move to right here, which is their final position, you might say, is 10 meters. What is their change in displacement? That is, how far have they gone in that time? Well, you can probably do that in your head, but to do it mathematically, you would say that it would be the final, that is 10 meters, minus 2 meters, and so you can come up with the fact that, okay, their change in displacement is 8 meters. All right, so wherever you see change in, it's always final minus initial. That's our difference between distance and displacement. All right, let's do an example, and then we'll be done with the section right here. So, I think you have a blank slide after this as well. I'm probably going to see if I can squeeze this all into this slide right here. All right. So, we are invited to a party at a friend's house. All right. So, here's where you live, right there. Friend's house is, I guess, I don't know, we'll call that west. All right. We'll call this west down here, and this direction east. Friend's house is west of your house, but you have to go to the grocery store to get some party supplies. All right, so you must travel to the grocery store to get some soda, and then walk all the way back to your friend's house where the party is. Okay. So, what distance must you drive for the trip? Distance means the whole amount of, you might say, ground that you cover, regardless of direction. So, all right, let's draw and see what distance you must drive. So you need to go from your house, 4.3 miles. I don't want to use blue because that's blending in too much. Let's go with red. You're going to walk 4.3 miles or drive 4.3 miles from your house to the grocery store. You're then going to drive, so I'm going to write that, so distance goes 4.3 miles. You're going to drive 4.3 miles back to your house, right? Plus 4.3 miles. And then you're going to go another 2.1 miles. 0.1 miles, mi, because m just means meters. Back to your friend's house with the soda where the party is. Okay? So 4.3 plus 4.3, that's what, 8.6, plus another 2.1, that would be 10.7 miles of your distance going from your house to the grocery store and back to your friend's house. By contrast, your displacement, I'm going to write this in green, DISP, is simply your beginning position, your final position minus your beginning position, all right? So here's your x initial right here. Here's your x final right there. I should put arrows over that because it means it's a vector. Okay? So, with position, we need to know what the, where's the coordinate system? Well, it says your friend's house, we consider that 0 right there, and your house must therefore be at 2.1 miles. We'll call the east direction, we'll call that positive. So the initial position equals 2.1 miles from the origin. Your final position happens to be the origin where your friend's house is, so that's going to be 0 right there. All right, so your displacement is going to be your delta x, your change in position right there. Now remember, delta always means delta x equals final minus initial. Okay? So that's going to be 0 minus 2.1 miles. And of course, you can do that in your head. That is negative 2.1 miles. Now, can you really walk negative 2.1 miles? No, you can't. You always add up distance when you walk. But if we consider the west direction the negative direction, then you would say, yeah, okay, you do walk negative 2.1 miles because you walk in the negative direction. If we say east is positive and west is negative, you ultimately, from here to a store and then back here, you ultimately, from beginning to end, walk negative 2.1 miles to your friend's house. And that's your displacement right there. So the difference between distance and displacement is as such. And that's going to be the end of our first section right here. So thanks for watching. Let me know if you have any questions. See you on the next one.